Welcome to the September issue of the American Journal of Physiology Heart and Circulatory Physiology video table of contents, or from the editor's desk. As summer comes to an end in the Northern Hemisphere, the journal continues to publish outstanding papers in cardiac and vascular physiology. This month we highlight two important reviews and several original research papers. So let's take a peek inside. In our first review in this issue, Patrick Crosswhite highlights and summarizes reports of ATP-dependent chromatin remodelers and their contribution to the development or maintenance of hypertension. Emerging evidence from hypertensive animal models suggests that induction of chromatin remodeler activity increases pro-inflammatory genes and increases blood pressure, whereas human studies demonstrate how chromatin remodelers may act as stress response sensors to harmful physiological stimuli. Importantly, genomic studies have linked patients with hypertension to mutations in chromatin remodeler genes. Collectively, evidence linking chromatin remodelers and hypertension warrants additional research and ultimately could reveal novel therapeutic approaches for treating this complex and devastating disease. Our second review article by Grossman-Rimon et al. Discuss hormonal and energy balance and cardiovascular risk factors in female athletes with amenorrhea. Female athletes display a high prevalence of hypothalamic amenorrhea as a result of energy imbalance. In these athletes with amenorrhea, decreased luteinizing hormone, follicle-stimulating hormone secretion leads to deficiency in endogenous estrogen. This review discusses the potential cardiovascular risk factors in athletes with amenorrhea as a result of hypoestrogenism, which include endothelial dysfunction and unfavorable lipid profiles. They also consider the potential to reverse the cardiovascular risk by restoring energy or hormonal imbalance along with the reproductive axis in athletes with amenorrhea. Taskaya et al. Examined the adaptive immune response in cardiac wound healing post-myocardial infarction. They hypothesized that CD8 positive T cells regulate the inflammatory response, leading to decreased survival and cardiac function post-MI. They performed permanent occlusion of the left anterior descending coronary artery on C57 Black 6J mice and compared them with CD8 ATM1 MAK mice, which are deficient in CD8 T cells. CD8 ATM1 mice had increased survival at 7 days post-MI compared with that of wild type. Despite having less mortality, 100% of the CD8-1 MAC group died because of cardiac rupture compared with only 33% of wild type. There was an acceleration of fibrosis in the infarct area as well as remote area in the CD8-1 MAC mice due to elevated soluble collagen implicating poor scar formation. Plasma and tissue inflammation were exacerbated as indicated by higher levels of CXCL1, CCL11, matrix metalloproteinase 2, and 9. They conclude that despite having improved cardiac physiology and overall survival, CD8 ATM1 MAC mice had increased innate inflammation and poor scar formation, leading to higher incidence of cardiac rupture. Pitra and colleagues investigated whether prorenin contributes to elevated circulating levels of neurohormones, such as vasopressin, during salt-sensitive hypertension, and if so, what are the precise underlying mechanisms. They obtained patch clamp recordings from hypothalamic magnocellular neurons that secrete oxytocin and vasopressin in acute hypothalamic slices obtained from sham and deoxycorticosterone acetate salt-treated hypertensive rats. They found that focal application of prorenin markedly increases membrane excitability and firing responses in magnocellular neurosecretory neurons of DOCA salt compared with sham rats. This effect included a shortened latency to spike initiation and increased numbers of spikes in responses to depolarizing stimuli and was mediated by a more robust inhibition of A-type potassium channels in DOCA salt compared with sham rats. They also found a significant decrease of plasma vasopressin in neuron-selective prorenin receptor knockout mice treated with DOCA salt compared to wild-type DOCA salt-treated mice. Together, these results support the activation of the prorenin receptor that contributes to increased excitability and firing discharge of magnocellular neurons and increased plasma levels of vasopressin in docosal hypertension. Finally, in a study by Reikwar et al., they determined the role of CD161A and CD68 positive macrophages and renal sympathetic nerves in cholinergic hypertension and renal sodium retention. Cholinergic receptor activation leads to premature development of hypertension and infiltration of pro-inflammatory CD160A positive and CD68 positive M1 macrophages into the renal medulla. Renal denervation is known to decrease renal inflammation. Immune ablation was conducted by injection of unconjugated azide-free antibody targeting rat CD61A positive cells. Nicotine induced premature hypertension, renal expression of the sodium-potassium chloride cotransporter increases in renal sodium retention, and infiltration of CD160A and CD68 positive macrophages into the renal medulla. All of these effects were abrogated by renal denervation and ablated by CD160A immune cells. Cholinergic activation of CD161A immune cells with nicotine leads to the premature development of hypertension in SHR. The effects of renal sympathetic nerves on chemotaxis of CD160A macrophages to the renal medulla increase renal expression of NKCC2 and renal sodium retention contribution to cholinergic hypertension. They conclude that CD168A positive immune cells are necessary and essential for the pro-hypertensive nicotine-mediated inflammatory response. Thank you for watching the September edition of From the Editor's Desk. As usual, we encourage you to sign up for the ETOC alerts and go to our website frequently to see what's newly published in the journal. Have a great month, and we'll see you in October.